I'll give you all a choice. So do you all, which would you want to do? Another more practice with the ISAT model with indistinguishable dyads, or we can move on.
I vote move on beyond indistinguishable dyads.
Okay. Any differing opinions, or does it feel comfortable to move on? Going once, going twice, silence is permission, we're moving on. Okay, then we will move forward and we are going to be focusing on types of variables within the APIM now. So we've talked about types of dyads. We have distinguishable and indistinguishable. And there's going to be three flavors of variables within the APIM. There's going to be within dyad variables, there's going to be between dyad variables, and there's going to be what's called mixed variables. So within dyad variables, for those of you thinking back to ANOVA, those of you who are multi-level modelers, within and between. So within dyad variables are differences that only occur within the context of a single dyad, but do not vary between dyads, right? So when we think about heterosexual couples and we think about gender, gender is a within dyad variable, because if your sample is all heterosexual couples, then every couple has one male and one female. And so the constitution doesn't differ across the dyads, but there can be husband and wife differences, right? And so again, you're going to have a variable that is going to be, that varies only within one dyad. Most of these variables are going to be binary, right? Theoretically, it's possible to have a continuous within dyad variable, but I literally have never seen an article with a continuous within dyad variable. So they're mostly going to be differences related to how partners are distinguished from one another. Again, gender, for example. For those of you who are interested in like household chores or gender roles and things like that, within dyad variable would be what percentage of chores do you do and what percentage of your chores does your partner do? It always has to add up to 100. And so you can have 60, some couples are going to be 60-40, some are 70-30, some are 80-20. And so that could be an example of a perhaps more continuous within dyad variable, where there's a lot more variation, more so than a binary variable. But again, I don't think I've ever seen any articles really getting at the more continuous nature of these variables. Again, most of it's going to be based on your distinguishing variable. So between dyad variables is the exact opposite. These are variables that are consistent for each member of the dyad, but are going to vary across dyads. Each dyad is going to have a different score, so to speak. So, for example, relationship length is going to be a between dyad variable, because I mean, you might get some argument about this, about when the relationship actually started, but generally, if you're studying heterosexual couples or couples in general, that relationship length variable is going to be identical for every dyad, for both dyad members, but it's going to vary across dyads. So some couples are going to be together a month, some couples are going to be together 2 years, some couples are going to be together 30 years, right? So that's going to be a variable that only varies at that kind of that relationship level, at that dyad level, right? And I will say now, and I will regurgitate again, some variables can be both within and mixed, depending on your research question. So it's not always gender is a within dyad variable, because if you have same-sex twins, those are indistinguishable, but you might have same-sex male twins and same-sex female twins. Gender becomes a between dyad variable. Okay? So don't make the assumption that that you're either one or the other. It depends on your research question in your sample and whether or not it's within or it's between. All right. And also, it's going to be important to think about whether or not certain variables that we think are between dyad are actually between dyad. So, for example, we can have number of children. That's what really kind of caught my eye and why I'm going to talk about this briefly. Is you can have, let's say you have, I do some co-parenting research. So I'm thinking about this, is you have people who are previously married and have children, and then they marry someone new and they have more children. So you have one parent with two sets of biological kids, different parents. And so if you're doing co-parenting research and you want to make the assumption that number of children is a between dyad variable, that depending on who they're with, it might be a mixed variable, which we're going to get to next, because if they're with their new partner might only consider the child that they have together as their child, and they wouldn't consider their stepchildren to be their children, right? And so then that can vary within and between. So again, this is the importance of really thinking about who your sample is, how you're going to recruit, inclusion criteria, exclusion criteria, and really hammering out your research question early on before you collect any data, because you could be making some assumptions that appear tenable, but might not in actuality be as tenable as we initially think. And then we have mixed variables. So mixed variables are the ones that we are going to see the most often. These vary within dyad and between dyad. So depression. So each partner in a dyad can have different depression scores. I have an 8, my partner has a 12. But also all the males in the dyad can vary. One male has 10, another has 8, another has 15, another has 0. Same thing for females. So the levels of depression vary within and between dyads. And these are the variables that we are going to be most often working with. Is going to be mixed. So mental health, relationship quality, substance use, personality, violence, anything else you can really see. I find that a lot of the times it's demographic variables that serve as distinguishing factors and how we distinguish dyads. So a lot of times that first page on your survey where you're gathering gender, sexual orientation, income, that's really important for how you're conceptualizing distinguishability in your dyads. But everything else that comes after that, all of your actual scales and assessments, those tend to be mixed variables, okay? And so here are just some more examples as I think about these within the context of my co-parenting research. So co-parenting relationship quality is going to be a mixed variable. People might differ on levels of co-parenting relationship quality among ex-spouses. Percentage of time spent with the child, that's going to be a within dyad variable, because between dyads, it's going to add up to 100% for every dyad, okay? But it might be that the very traditional dad gets the kids every other weekend, and that's about 15% of the time or something like that. Maybe it's 30, I don't remember. Don't do the math on it. Don't check me on the math, but it's some small percentage, and the mom gets them the other 85% or whatever it is. And so that's going to only vary between or within dyads. And then you have a between dyads variable, which is time since separation. Time since when partner A said to partner B, this relationship is over, right? That's going to be the same for every couple, but it's for every dyad, but it's going to be the same value for each dyad member, okay? And again, this is where you want to be careful in your assessment, because if you ask a husband what percentage of chores they do and what percentage, that same question to a female, you're going to get, I guarantee you, those numbers are not going to be symmetric. So you want to think about how you're actually going to kind of create those variables. Are you going to take a mean of those two? And then that's how you're going to create your within dyad variable. So again, these are the decisions that you should be making before you collect any type of data. Because it's easy to think about that, but if we ask the same questions to every single person, especially on these within dyad variables, we can run into trouble really quickly. And then also thinking about, if you're only going to ask one dyad member this type of question, what's the theoretical rationale? Why would you only ask moms what percentage of time do the children spend with dad? Why wouldn't you ask dad that? Right. So again, these are all the decisions that you should be making on the front end of your studies. All right, so again, I don't feel the need to belabor the within and between dyad variables anymore. So we will go ahead and skip over this. So next we are going to be talking about dyadic patterns. And so essentially dyadic patterns are, in my eyes, categorical ways of describing the ratio of actor to partner effects within dyads. I find that that dyadic patterns aren't all that important. So I've only run these in one of my papers. To me, it's a categorical kind of indicator to describe the nature of the relationships. And so I'm not sure what it gives me that I couldn't just kind of look at within the context of the study. There are occasional cases where the actor and partner effects are fairly close together, so you want to see if they're statistically different. But if they're not close, I generally don't run this. I generally, if a reviewer asks me to do it, I will do it. But I generally don't put a whole lot of weight onto dyadic patterns. But I'm going to talk about it because you will see it discussed. So again, it's a ratio of actor to partner effects. And so when you have actor-oriented patterns, that means your actor effects are going to be highly significant, and your your partner effects are going to be either 0 or very close to 0. So if you have an actor effect of 0.40 for both partners and your partner effects 0.08, that's going to be an actor-oriented pattern, right? Even though that 0.08 might actually be statistically different from 0, when you actually take the ratio of those, it's going to be highly skewed in favor of actor effects having a much more potent effect on the outcome. Then you're going to have partner-oriented patterns, which is just the inverse. So this is where you have a partner effect. Both the partner effects are astronomically large compared to the, compared to the actor effects, right? And then you can have a couple-oriented pattern where they're equal. All right, we're going to go through examples of each of these, where the actor effects are not statistically different from the partner effects, again, within that dyad and on average. Okay. And then you can have the contrast pattern, and this is the one where it's kind of harder to get your head around. It's where your actor and your partner effects equal 0. So that means your actor effects are positive and your partner effects are negative or inverse. Your actor effects are negative and your partner effects are positive. And when you take the ratio of them together, you get 0 or close to 0, right? And then you have the domination pattern, which is where you have the actor and partner effects are significant, but only for one member of the dyad. So there are no actor effects for dyad member 1. And there's no partner effects from dyad member 1 to dyad member 2, number 2. But for dyad number 2, they have both actor effects for themselves and they have a partner effect influencing partner 1, right? All right, so I'm just going to save for right now because we'll get into it a little bit later, mostly tomorrow. You will use phantom variables, although that's not the only way to test dyadic patterns, but essentially those are latent variables that are not really attached to any indicators within your data set. And they're tricky little guys that you need to specify in a very particular way, but I will leave that for a little bit later. So here is an example of an actor-oriented pattern. This is where you have the husband's job satisfaction and the wife's job satisfaction. And the husband's job satisfaction is positively associated with his own negative affect, but how satisfied he is with his job does not influence the partner and their negative affect. Likewise, with the wife, her job satisfaction does not influence the husband's level of negative affect. That partner effect is either 0 or close to 0. All right. So you only see these significant effects on actor, and they're non-significant on partner. All right. So example of partner-oriented. This is your own level of how attractive do you feel, or how attractive are you? And your sexual satisfaction. So how attractive do you feel probably isn't going to impact your own sexual satisfaction, but it might impact your partner's satisfaction. and vice versa, right? The couple-oriented pattern. You know, when the more and more you and your partner joke around and are playful with one another, that's going to be probably positively associated with your own levels of positive affect and your partner's. And the more your partner feel like they can play around with you, that's probably going to be associated with your levels of positive affect and their own, right? You're engaging kind of shared playfulness, which elicits happiness out of both partners, okay? And then this is where you're going to have a contrast pattern. This is where it kind of begins to get a little tricky, is the amount of time you spend with friends among heterosexual couples. So the more time you spend with your friends, you probably like hanging out with your friends. So that's probably going to be positively associated with how happy you are in general, right? But the more time you spend with your friends, the more unhappy your partner might be, because it's time spent with your friends and not time spent with one another, okay? And so likewise, the more time your partner spends with their friends, the less time they're spending with you, which is probably going to decrease your overall level of happiness. Okay. Any questions about the contrast pattern, or it's open to any of the patterns, but particularly the contrast pattern? Okay. So now we're going to go to the domination pattern. So this is a new. Is there a question from any of the Zoom folks? No, okay. So the domination pattern is a little bit newer. So the first four patterns were things that Dave Kenny has been talking about for over 20 years now, probably closer to 30 now. But the domination pattern is newer. I'm not sure exactly when it was developed, but I'd say the last 10 or 15 years, somewhere in there. So the domination pattern is, again, when the effects are only significant within one person. And so it took me like half an hour to finally figure out what's an example of a domination pattern, because I don't really see it in the empirical research. And this was the best thing I could come up with. And the example I came up with is, me being a family therapist. I thought about, my levels of empathy and how that would impact my clients. And my clients probably want me to be empathetic towards them, right? And so the more empathetic I feel I am, the more I'm probably going to the higher I'm going to rate my therapeutic alliance with them. Because I'm really empathetic, which means I care about them, which means I'm going to assume that they care about me, right? But also, the more empathetic I am, we're going to presume empathy is a good thing here. The stronger or the closer that the client is most likely going to feel towards me, right? Because if I'm not empathetic at all, my partner's probably the client's probably not going to come back, right? But when we think about it the other way, how empathetic the client is towards me as the therapist, that's probably not going to impact the therapeutic alliance, or at least it shouldn't, right? Otherwise, we moved out of the therapy realm and into, something that's not as therapeutic, right? And also their levels of empathy is not going to impact their own views on the therapeutic relationship, but it's also not going to impact my views on the therapeutic relationship. I can have empathy for someone who doesn't really have a whole lot of empathy for me. That's actually probably a good thing. We probably don't want that partner effect to be statistically significant, right? Otherwise, again, we are potentially running into ethical problems in the therapy realm. So here's a way to kind of view those phantom variables that I had mentioned. And again, these are variables in the model that aren't necessarily represented by any observed data, but you need to estimate them in order to get that ratio of the actor to partner effects. And so that I've highlighted these 6 phantom variables in the red squares. All right, so that's just a pictorial representation of of phantom variables. So again, I've already said I'm not a huge fan of dyadic patterns, so we're not going to walk through it in M+. I will absolutely give you syntax to conduct dyadic patterns within M+. But again, I don't see it as giving much information, honestly, unless you have a couple-oriented pattern and you want to test whether or not those actor and partner effects are significantly different from one another. I don't find it to be all that informative, all that useful, but you will probably hear a lot of people who argue with me or about that. So again, it's to each their own, and I'm not opposed to doing it. To me, it feels kind of like an unnecessary step, especially when I can look at the patterns and see, okay, the actor effects are 0.40 and the partner effects are 0.15. I know what my pattern is, right? That's not going to be a couple-oriented pattern. That's going to be an actor-oriented pattern. I'm not sure if I've already done it or not. I posted 3 or 4 tutorials. I'm not sure if I've done dyadic patterns yet, but if I haven't, that's one of my projects for this summer. So you will have access to them. And here are some papers. The Liederman and Kenny 2010 is a great paper. People are creating new, normally we use the K parameter for Larry Kudek, who's an early pioneer in dyadic research. That's the gold standard in terms of dyadic pattern parameters, but now people are inventing new ones that you will see in this Yang paper in 2023. And now we are going to be moving into the extensions of the actor-partner interdependence model. So now we're going to be moving into the mediation model, all right? Any questions before? I want to make sure we have the foundational principles of the APIM understood before moving on to an extension that will get a little complex. Okay. So essentially we can just build up and scale up our APIM, our baseline APIM into a mediational model, just as we can move from a direct effect to a mediated effect in linear regression or whatever other ways you estimate your direct and your indirect effects, right? So you can assess the extent to which there like a mediator that I report on and that my partner reports on indirectly associates my independent variables to my own outcomes or to my partner's outcomes. And so I think that's what the APIM mediation model does that is so fascinating, is that we can actually track the patterns of association from my, let's say, depression to my partner's relationship quality. So let's say I'm depressed, and so I'm less attentive than I normally would be, right? So I'm withdrawn, I'm moody, I'm not all that attentive to when my partner's upset. I make it all about me, and so the higher I am on depression, the less empathetic I am towards my partner, right? The less empathetic I am towards my partner, the more they are going to be unsatisfied, right? And so again, we can track how an individual level effect is actually manifesting dyadically and in the relationship. So I think that's one of the really, really cool things that I've come to love about the actor-partner interdependence mediational model. All right. So in sum, this mediation model allows me to test pathways from my own outcome, my own IVs to my partner's outcomes, my partner's IV to my outcomes, and we can track, I think, 8 different indirect pathways linking the two. So everything we do in the APIM mediation model just is scaled up from the baseline APIM model. So we also want to test an ISAT model, right? So when we're estimating an APIM, we probably don't need to test just the IV and the DV in the ISAT model. We throw it into an ISAT model with the IV, the mediator, and the dependent variable for both partners in there, and then run the ISAT, all right? And then we can have within, between, and mixed variables as well. So here is a pictorial representation. Again, I'm a very visual person, so you will see lots and lots of graphs, lots and lots of diagrams about the APIM mediational model. All right. Again, it's getting a little more complicated, but it's really quite simplistic. It's nothing more than kind of two mediational models kind of side by side. All right. So in the APIM mediational model, we have 27 free parameters. All right. We have 6 actor and partner effects, which are our covariances. We have means and variances for each independent variable. We have an intercept for each, and a variance for each dependent variable, or perhaps variance of their error terms, depending on how you're specifying your model. 3 covariances between your IVs covariate, your mediators are covariate, and your dependent variables are covariate. So again, this is where you can, this is again getting a little bit more advanced, but the way you can determine the number of parameters in your model is if you use the formula P plus P times P plus 1 divided by 2. All right, so those of you who have had your SEM class, you've probably seen this formula before. So this P here is going to be your mean structure, which we largely ignore in structural equation modeling unless we're doing something along the lines of growth modeling or perhaps latent change scores. So a lot of times you'll even see it's just P times P plus 1 divided by 2. All right. If you're looking just at the variances and the covariances among your factors, because the mean structure is saturated, right? That's why we kind of drop that first P in structural equation modeling. All right. So here's just an example paper of looking at using some co-parenting data, looking at how does early childhood maltreatment impact co-parenting. And I'm suggesting that it's mediated through stress. All right. And so here is what we ended up finding. Found actually some really interesting stuff. So we can see here we have, the more mothers were maltreated in childhood, the more stressed they were, and the more stressed they were, the lower the co-parenting relationship. And then we found the exact same effects for fathers. So the more they were maltreated, the more stressed they were, which led to a lower quality co-parenting relationship. But we also found, again, this is what I think the beautiful part about the model is, we found partner effects. So we found a direct effect from fathers' reports of childhood maltreatment, abuse, and neglect. And it was negatively associated with mother's co-parenting relationship quality. So that means there is some reason why father's abuse and neglect before the age of 18 is influencing mom's relationship quality of co-parenting, but it's not in our model. All right. And so this is where we have to, again, put on our theoretical hats and think about why might this be, right? And that might be mediated by other characteristics in relation to divorce. So if you think about maltreatment, there's a loneliness, there's isolation, there's shame. And so that might those underlying emotions might also play out in the divorce process somehow. Right? There might be responding to maternal gatekeeping or whatever it might be. So again, a really interesting finding. Likewise, and again, this is what I think is even cooler, perhaps, the more dads are stressed, the higher moms report that the co-parenting relationship is stronger. So essentially, moms like it when dad co-parents are stressed out, essentially, right? And we can probably think about several different ways to get at that. But again, I think this adds a whole new level of nuance to what is happening that wouldn't be ordinarily captured in just if you're just asking moms and dads separately and not doing dyadic analyses. Again, just going based off of where I envisioned us going and what I've heard already is we're not going to test the APIM ISAT model, because essentially it's the same thing as what we've already done. You're just constraining you're adding two more parameters. So the code should be, it'll be provided to you, but it'll be essentially the exact same thing. You're going to get the exact same, you're going through the exact same process. So I don't feel the need. And if someone wants to, I'll absolutely walk you all through it. But I think it sounds like I'm sensing you all have a pretty good grip on the ISAT model. So, I referenced this a little bit this morning around equivalent models. I'm going to spend just about 30 seconds on it, and that's really about it. The reason I had you code on statements is because the M+ demo version doesn't allow you to have more than two independent variables. And if you use a with statement, it's going to be an independent variable, all right? But what this is, and if you look at these outputs, you get the exact same log likelihood value. This negative 981, it's identical, right? The chi-square, identical, except one is a regression coefficient that's accounting for variance, and one is a covariance. So this is what's called an equivalent model, not an alternative model, an equivalent model where you have the exact same log likelihood. You have the exact same model data fit, even though you're parameterizing your model in two distinct different ways. And believe it or not, there's actually hundreds of alternative models to this that will give you the exact same log likelihood. That should scare that's at least I'll say that scares the crap out of me. That I can parameterize this model in a dozen different ways and I get this exact same log likelihood value. That means they're empirically indistinguishable. We cannot say this one is better than this one. This one is more correct than that one. We have to go solely based on theory. And that's why longitudinal data is so helpful, because that wipes out a ton of equivalent models because you now have temporal ordering, right? So that's all I'm going to say on this, but this is a famous paper by Lee and Hirschberger. They talked about equivalent models. And so what you can do, and I think I mentioned it briefly in this morning, is constraining the actor effects to be equal, constraining the partner effects to be equal, constraining the actor effects to be equivalent to the partner effects, and vice versa. This just scales up, and now we can really look at comparisons across dyad members, where we can constrain all of these paths to equality and see whether or not there's moderation, because that's essentially what we're testing here. And there's a whole bunch of different paths that we can constrain to equality, right? And people, generally in dyadic research, people don't do that. And I think the reason why is we've been beaten to death about the replication crisis. And so if we didn't explicitly create a theoretical rationale in our introduction for every single moderated path, then we can't test it. And I think that's kind of ridiculous. I think we need to be intentional about how we're going about this. But if I have a path that's 0.40 and 0.32, that might go against kind of what not necessarily go against, but that might not have been something I thought about or the literature even says. But if I don't constrain that to equality, then I don't know whether or not the effects are different. And to me, that's actually how you move theory and research to a new direction. You begin testing these constraints and seeing whether or not the model's actually different or not. And to me, you just own up and say, I did not hypothesize these. I did not think there would be an effect. There's no theoretical rationale, but I constrain them to equality so that I could determine whether or not stress impacts the co-parenting relationship the same way for men and women. This can be a fruitful avenue for theoretical refinement and more theoretical research, right? And so I think we've been beaten to death with just not being with the replication crisis, that it's actually, I think it's constrained us too much, where we have that we're really kind of scared to make any modifications to our model, all right? Because unless your introduction's 60 pages long, there's no way you can do a whole lit review and hypothesize moderation for all of these different parameters in 8 pages. I just don't think that's possible. So again, be honest with yourself. around, and don't just go around constraining things just to constrain things, but if you think there might be something there, then I'd say go ahead and test it and just be honest about whether or not you expect that to be equal or not. All right, so here are the total indirect effects. You have 8 of them, that many, 8 of them in the APIM, all right? And so we're just going to walk through each one. So we can have an actor-oriented effect for partner X. We can have, or for partner 1, I'm sorry. For partner 2, they can have a partner effect, and there can be indirect effect that way. There can be a partner effect. Those are extremely difficult to detect. You need probably over 1,000 dyads to detect that, because partner effects tend to be really, really small. And when you're multiplying 2 really, really small numbers together, you need a big old sample. I think I have a sample of 926 dyads, and I can't remember what I ran, but I did a post hoc power analysis, and I still think I was only like 0.65 or 0.70, and I had almost 1,000 dyads to detect partner. So they're hard to detect. Then you have some more actor partner, and then you have, I don't know what's going on. You have the actor effect for the other dyad member, and then you have the partner actor, and then you have that actor partner indirect effect. All right. And so here are the actor effects. So I ran an actor partner interdependence mediation model looking at relationship mindfulness, dyadic coping, and relationship quality. Dyadic or relationship quality is our outcome. Dyadic coping is our mediator. All right. And so all of these in red are going to be our actor effects. All right. So we're going to have, I believe, was it 8 of, was it 2, 4, 6 of them, right? And then we have partner effects highlighted in blue in those boxes, right? And so, again, I'll be just very brief here. Run these, constrain these paths to equality. If you think that if you're just eyeballing it, those might be the same, those might be different. Run the test and then report it in your results. And again, clearly state, I'm repeating myself, but I'm doing that intentionally, that this was not hypothesized, but after evaluating the model, we wanted to see whether or not these were significantly different from one another, because these have implications for theory, right? Or implications for intervention, or implications for future research. Because again, we're not going to make any progress if we don't at least push the boundary a little bit. Right? Another thing that I think is super cool is we talked about constraining the direct effects to equality. You can statistically compare the indirect effects. You can say whether or not the mediated effect for men is exactly the same as the mediated effect for women. So I think that's super cool. And that's something we don't ever do, even in single individual-based models. When we have kind of two independent variables, 2 mediators, and 2 outcomes, we can compare those mediated effects. And we can say, this pathway is stronger for men than for women. Again, important implications for theory and for research. All right, so there are several ways to test mediation. And this is not unique to the APIM, but I'm going to just briefly go over it. The first is bootstrapping. And this is where you have 5,000, you generally use 5,000 bootstrap samples, where you're resampling with replacement. So you have your sample of, in our example, 125 dyads. And then you're going in and you're picking out, okay, dyads, you're not in the sample, dyad number 43, you're in here twice, dyad number 52, you're in here 4 times, dyad 2, you're out of this sample, and you're repeating that process over and over and over and over and over again. And what that gives you is it gives you a sampling distribution of indirect effects that we hope is normally distributed. All right. And this is the gold standard for testing mediation now. I've done this before. I will do it again, but when all possible, I do not run bootstrapping procedures. Recent research has found that there's type 1 errors in bootstrapping procedures, even with bias-corrected confidence intervals. Even those are asymmetric confidence intervals, but they're still problematic. And my belief is that it's because we're assuming normality of the residuals using maximum likelihood. We're not making any corrections for non-normality in our residuals. And so that's leading, and I already talked about it. Remember, if we have non-normality, it's downwardly biasing our standard errors and upwardly biasing our p-values, or downwardly biasing our p-values. And so we're going to run into type 1 errors. So that's my inferential anecdotal experience with them. And so this is what it gives you, a bootstrap sampling distribution of indirect effects. So if you did this 5,000 times, this is the distribution of the indirect effects that you would get after repeated samples. And here is the M+ code for maximum likelihood. And when we move into M+, testing the APIM EM, we will test it both ways. So you will get experience testing it with bootstrapping, as well as robust maximum likelihood, which is my preferred method of testing indirect effects. And the reason that you can't do bootstrapping is because in robust maximum likelihood, you have a scaling correction factor, which doesn't allow you to bootstrap. All right. So you can only do robust standard errors, and then you can only estimate a confidence interval. And in M+, we use delta method because that is the default. All right. That's how M+ calculates the indirect effects. And so again, we will go over that when we move into the APIM EM, which is right now. All right. So I will try to get access to my folders without, let me move this down. Okay. So it should be the exact same data files you used as this morning. So it'll be the APIM EM input file and the couples.dat data file. Let's see. And you should have the syntax. This is my folder, but you should have the APIM iset in there as well, available to you. All right. So the model we are going to test is each partner's depression to each partner's dyadic coping to each partner. Can't see?
I can only see the slides.
Mm-hmm. Okay, hold on one sec. Let's see, all right, try that.
Thank you.
All right, so all of this will be exactly the same. First, we're going to do robust maximum likelihood, and then we'll do bootstrapping next. So here is our model. And so the first thing we are going to do is we are going to specify, I always work backwards. So I do my dependent variable first, and then I'll work to my mediators. But again, the coding order doesn't really matter here. And so here we have our dependent variable for males, relationship quality, and that's going to be regressed on the mediators for men and from women, and the independent variables for men and for women, right? And so implicitly, I am suggesting to you all that I think there's a direct effect between depression and relationship quality. Otherwise, you wouldn't estimate that. That's based on your theory, right? But to run the model, I'm just going to run you the full saturated model, and then maybe we can play around with it to see what happens. This will be male outcomes on mediators plus IVs. And then this will be female outcomes on mediators plus IVs. All right. And you can do this all on one line, or you can do, CSIM on dicop men CSIM on dicop. And if you want to constrain parameters, you're going to have to do it this kind of extended way, all right? But to me, just for right now, I'm just showing you the shorthand way. And technically, if you want to get even lazier, which I often do, you can do this, CSIM on, and then just do this. Right? You are not restricted to one dependent variable on the left-hand side of your on statement, right? You can do whatever your heart desires. I'm kind of showing you a little bit of both here so you can get a sense of the M+ syntax. Now here you are just regressing your two mediators on your two independent variables. So you'll notice here that I have two variables on the left-hand side, all right? And then we have our covariances, right? Same thing as in the baseline APIM. And then this is how we calculate our indirect effects. And with indirect effects, I don't know why M+ does it this way, but you cannot do this, CSIM. Don't know why, but it doesn't allow you to have more than one indirect effect on one line. So this one you have to do one at a time. That being said, the good thing about M+ is you don't have to specify all of the indirect effects. Notice that I only have 4 lines of code, but we're going to get out 8 indirect effects. So as long as you tell M+, here is my IV and here's my DV, it's automatically going to calculate every possible way in which your IV is going to be related to your DV, right? And then plot 3, again, you don't really need it. Outliers, you don't really need it. Again, that's just my own idiosyncratic things I include. Generally, you want SAMSTAT. I always include residual, STDYX. We want that. Mod indices, it's not relevant here. And then your confidence intervals. You can go ahead and run it. All right. So again, checking your statistics and your sample. All my observations are there. I have the correct number of groups. Just briefly skimming over the correlations and the covariances just to see if everything's in line. I look at not every time I run a model, but the first time I run a model, I always look at my univariate statistics, because if there's a missing data code that's coded incorrectly, it's going to show up and you're going to have an outrageous mean or an outrageous skewness or kurtosis or something like that. So I always make a point to at least look at this the first time I'm running a model, just to ensure I don't have any weird values. Again, this is a saturated model, so all of this is going to be 0 and all of these are going to be 1. And we'll just scroll down to standardized estimates. All right. And so what we can see here, again, we only have 125 dyads, so we're at like the bare minimum threshold in terms of power that's generally recommended. And we see we have an actor effect for the mediator, but we do not have an actor effect for the independent variable. All right, so this is male depression is not directly related to male relationship quality. All right. Over here, we have a significant partner effect, or a significant actor effect, excuse me, and a significant actor effect here, where female depression is associated with female relationship quality outside of the indirect effect through dyadic coping. All right. So here we have what would be called full mediation. And here we would have what's called partial mediation. All right. And so here we have depression. The more depressed you are, the less you cope with, less you cope well with your partner. And that's significant for males, that actor effect. And the partner effect is non-significant. And we also have another actor effect over here for the females. And there is no partner effect over here. All right. Let's see if I can get the diagrammer to work. It's been a pain in the butt. So here would be your here would be the model if you were a more visual person. Let me move the Zoom stuff around. All right. And I generally don't use the diagramming feature because once you have covariates in here, it gets real messy real quick. But essentially, this is what our model is implying. All right. All right, so I'll exit out of that. All right. So now what we're going to do is we're going to constrain a pathway to be equal across dyads. All right, just to see what happens. All right, so let's pick a path. Let's look at the effects of depression on dyadic coping. So we're gonna do that and constrain those to be equal across gender to see if there's moderation. So we'll need to adjust our syntax to accommodate the labels. And so for the male, we're going to have one effect here where it's CESD, CSDM. And then we'll just throw M1 for male. And we'll throw that in there. And then I tend to do these one by one. You can constrain 3 or 4 effects to be significant in one model. But if you get a chi-square of 10 and it's significant, you don't know which effect is actually driving that. So you have to go back and do it one by one anyway. So I prefer to just do it all at once. All right. And so the partner effects, we're going to leave those alone right now. We're only going to consider actor effects. All right, we want to constrain that partner effect. P1, probably P1's a better label. Now we save it. All right, so now we should have 1 degree of freedom. All right, so now we can actually evaluate model data fit at least a little bit. And the chi-square is 0.133, which means it's highly, highly, highly non-significant. The critical value for a chi-square test is 3.84 for 1 degree of freedom. And we can say now that the effects of depression on dyadic coping it's not statistically different for men and for women. All right. And now we're going to go ahead and you can move over, and we're going to go ahead and test the partner effects now. Let's do P1. And I generally only test the effects when one is significant. All right. So if you have 2 non-significant effects, what's the point of saying whether or not they're significantly different from one another? To me, there's not any information to be gained in that way. But if one's significant and one's not, you can still compare them to see whether or not that difference is actually statistically significant. Oops. So we'll go ahead and we can run this. I think this is one of those events where they're both non-significant. So again, not statistically significant. And now we can say we tested the relative strength of these effects and they're not significantly different from one another. Okay, so now let's run it with bootstrapping. Actually, before we do, I'm going to go back to our original model. And I want us to pay attention to our standard errors. So here's our model. We'll go down to standardized and just ballpark it. All of the standard errors are around 0.10, 103, 105, 0.09, 0.09, somewhere in there. All right. And now we'll go and we'll do some bootstrapping. So you can type in reduce or get rid of that R, and then you can type in bootstrap. And then I'm only going to do 500. Normally you want to do 5,000. Actually, I'm going to do less than that because my computer's probably getting stressed anyways. And that's all you need to change to test the bootstrapped indirect effects. Okay, and it'll run really quite quickly. You'll get some error messages saying you can't get mod indices and things like that, and outliers with bootstrapping. Don't worry about that. Now we're going to scroll down. You'll get everything else is exactly the same. And you'll notice our standard errors went up a little bit. Not a whole lot in this one, but they did go up. They did go up a little bit. Or actually, maybe they went down. They're relatively about the same. So that means in this data set, you could probably use robust maximum likelihood or maximum likelihood bootstrapping, and it doesn't look like we would have come to any different conclusions. That effect is still non-significant. This was kind of the one I was watching because with bootstrapping, I may have actually guessed that this one would fall to be less than 0.05. But in this analysis, it's not all that important. So we can probably not really worry a whole lot about which one we report, but my view is if we didn't get any different estimates or we wouldn't have made any different substantive conclusions, just report robust anyways. Because that's, to me, is a little bit more conservative and a little bit more accurate because we can actually look at the residuals of our variables, and they are going to look icky. Actually, let's instead of doing this, let's do histograms. So let's do a histogram, and we will do the residual of. We'll go through all four actually. Dyadic coping. So not bad. Nothing to brag about, but I mean, more or less, it's normal-ish. That one's getting a little, now we're seeing a little more skewness, a little more kurtosis. The means over here around negative, 4 or 5. We want it to be kind of over here. So our distribution has definitely shifted. So CSI, again, not great because our mean should be 0. That's one of the assumptions, is that our mean of our residuals is 0. So we're definitely not there, but it's not horrible. This is yucky. This is not good. It's, you can see the pretty extreme tail, and it's also highly skewed as well. So again, this is the way our residuals are going to look 95% of the time. So let's just provide a correction and not have to worry about it. All right, so we can move back into the PowerPoint. So I'm gonna try the screen and see if this works. Where is it? Oh, there you are. All right. All right, so as you would expect with indistinguishable dyads, we talked about the ISAT model, you just scale that up. You constrain all the means, the variances, and the covariances to be identical when you're testing mediation with indistinguishable dyads, right? So again, this is the same slide as earlier when I was talking about constraining the APIM EM with distinguishable dyads. We compare all of these. With indistinguishable, this is the way you have to estimate the model, okay? So we're going to go ahead and skip over that. So now we're going to get into just a very brief discussion about power in the actor-partner interdependence mediational model. So again, I vented about the fit statistics earlier and how we've overgeneralized, this is the value we need. I'm going to say the same thing before I talk about power. This is a Monte Carlo simulation study, which means they only tested a specific effect size. You can't test all, if you think about all the different effect sizes that go into a regression, we have 6 actor and 6 partner effects. And if you want to vary those to see the power for every single one, you're going to be having hundreds, if not thousands, of different cells. of your power at a given sample size. So again, this is a general requirement, and you should be doing a priori power analyses before you even collect your data to see if your study even has a fighting chance in order to detect something. So with distinguishable dyads, you need around 250 couples to detect a partner effect in general and on average in the social sciences. And this depends on your measurements, right? If you think about partner-oriented patterns, if that's your research question, then you probably need less. But in general and on average, you will need around 250 couples to have a prayer at detecting a partner effect. But in distinguishable dyads, cut that in half. All right. So you only need 121 to detect a partner effect in indistinguishable dyads because the paths are constrained to be exactly the same. All right. And you only need 45 people to detect actor effects with indistinguishable dyads, whereas you need to double that when you have distinguishable dyads. All right. So again, the purpose of talking about this is to give you a general framework of how many people you're actually going to need for your prayer to have a prayer of actually not running into a type 2 error. Okay. And if you have high skewness and high kurtosis, double your sample size. So that means you're up to 500 couples if you have highly skewed data to detect partner effects and 181 to detect actor effects, right? So again, if your hypotheses are really oriented around those partner effects, then you need to be collecting data and make sure you get to these numbers. Otherwise, you're just failing to find something that's actually there. You just didn't have the power to detect it, all right? So Lederman and colleagues, they ended up recommending 120 dyads for these indirect effects, for actor effects. But you need 800 dyads to detect an indirect effect when there is a partner effect from X1 to the mediator. So my independent variable is predicting my partner's mediator, need over 800 dyads. If you have skewness and kurtosis, 1,600 to detect those types of dyads, right? And I think they only use maximum likelihood. So my guess is if we throw robust maximum likelihood in there, that number is going to go down a decent amount because it provides a correction, but it's still going to be a lot, right? So if you have a study focused on how partners influence each other between your IVs and your mediators, better go get some NIH funding and like R01 level NIH funding, right? Because the average cost to recruit a dyad, to get complete data for dyads and Qualtrics, it costs $102 for a dyad per couple. You can try to recruit other ways, but it creates a headache, and you can pay them 20 or 30 or 40 bucks. But it can get really costly and really time intensive. All right. So that's my dish on statistical power. So there's my disclaimer. I am not saying you need 125 dyads. I'm not making any recommendations other than giving you a general framework to know how to adequately power your study. And it doesn't mean you don't collect 50 because prelim data is not bad. You know, if you are applying for an R21, get prelim data and say, we see this effect size is 0.30. We just have a high standard error because we have not a lot of people. Give us a lot of money to go get more people, all right? So prelim data isn't bad, but just know the limitations of it. Okay, any questions before we move on to moderation? We'll get part of the way through moderation, then we're going to take our break. All right. All right. APIM moderation, it gets complex really quickly, and it gets super confusing. So just let me know if you get lost, because it took me time to really get my head around moderation, because we're looking at moderation within dyads, we're looking at moderation between dyads, and we're looking at moderation at both, within and between, using mixed variables. Within dyads will be really easy. It's the between dyad stuff that it's where it gets a little complicated. So just as a disclosure, M plus, because the way interaction terms are done, they're the multiplicative variables of two IVs. So therefore it's a third independent variable. So M plus will not let us estimate it using the demo version. So we're going to throw a nonsense parameter in there, and that's how we're going to get around it so we can estimate it. Again, I got to get something, a little something out of this other than the joy of just talking about dyadic data. And so I'm going to go on a rant on how our field is overly focused on direct effects. I think to me that's a problem in pretty much all fields, but I think especially in the social sciences, we're so focused on how one thing predicts another, how predicts another, predicts another, predicts another. So we create these really beautiful introductions and these literature reviews and these theories, and then we test mediation, we find something that's significant, and then what do we do in the discussion? We talk about variables that weren't in our model because we believe that's the actual mechanism underlying the associations between our IV and our DV. So we're just adding in another parameter that's not in our model, but it's another direct effect. Does that make sense? So I'll be more specific. So let's say my history of maltreatment is associated with my relationship quality with my partner, just a baseline kind of APIM. All right, and we also estimate my partners. And then in the introduction, we make this beautiful theoretically derived argument. And then in our discussion, we found a significant relationship. The more maltreatment I experienced in childhood, the lower was the quality of my relationship. And a possible mechanism is depression. So again, we're just adding in another direct effect, when in reality, we need to really be focusing more on moderating processes and figure out for whom and under what circumstances these effects actually exist. And that's why I hate population studies. I can't stand nationally representative data. And you say education has a beta weight on depressive symptoms of 0.18 or negative 0.18. You're saying that that beta weight applies to every single person in that sample? That makes me cringe. Because it might be there's some groups where it's 0.09, there's gonna be other groups where it's 0.30, and we're kind of making these really, really strong inferences about these parameters. And even from a public health perspective, you can make the argument, this is what it's like on average, but what if it's 0.30 for one group and 0.06 for another group? You're wasting a whole bunch of time and money trying to sell your idea in an education-based intervention on the group where it doesn't even work. So we need to be considering these moderating processes, and this is particularly true in dyadic research because direct effects are really easy to think about and really easy to estimate. Moderation is hard thinking, right? And people don't think about in dyadic research, under what circumstances do I influence my partner, or does my partner influence me? And that's what we're going to get at today, right? So here is a visual representation of a moderation model that you've probably seen in at least one or two, if not all of your stat courses at some point, right? Where the level or the relationship between depression and sexual satisfaction is contingent on the level of attachment avoidance, right? So here are our equations, which I'm not going to get into. Moderation is needed because it violates the assumption without moderation of linearity in the parameters, all right? So that's when remember I said earlier on this morning, your slope, that beta 1 has to be the same, right? That's the assumption that we make. It can't change as a function of group or over levels of your variable. And so when you have moderation, your slope for one group is 0.20 and for another group it's 0.30. That violates that assumption. It's also called the assumption of parallelism that people talked about in ANOVA and ANCOVA 30 or 40, 50 years ago. And so that's what it allows us to do. It allows us to not violate that assumption. Right? Moderation is exceptionally difficult to detect, exceptionally difficult. If I see an R squared of 2% of the variance accounted for by my interaction term, I am jumping for joy because most of them are going to be around 1%. I was reviewing an article for a journal and they found an interaction term accounted for 17% of the variance. They had like 70 people. And so I'm like, red flags, sirens blaring, like there's something going on there because that's unheard of. I've never heard of anything over 4% really. And they found like 17%. So that's just to give you a context about variance. So here's a graphical representation of moderation. This is from a paper I published with a student, I don't know, 3 or 4 years ago, where we found a buffering effect, whereas maltreatment gets higher and higher and higher. PTSD goes up, but it goes up at a different rates based on how much you practice yoga. So the more yoga you practice, high yoga, I think it's like 4 times a month, you have slower increases in PTSD as maltreatment goes up. You can also do 3-way interactions. Here's a paper I'm working on with that has a 3-way interaction between, what is it, maltreatment, perceived stress, and gender as it's predictive of allostatic load. And you can kind of see what that looks like. All right, so within the APIM, there are, again, 3 ways we can test moderation: within dyad, between dyad, and mixed. And so we'll walk through an example of each. Within dyad moderation, that's where we're going to start. You only do with distinguishable dyads. Why wouldn't we test within dyad moderation with indistinguishable dyads? They're already constrained to equality, right? All the paths that could possibly differ as a function of dyad membership, they're already constrained to be equal. So if we want to think about whether or not an actor effect is the same for males and females in a heterosexual cisgender couples, sure, that makes perfect sense. But same-sex twins, we've already determined that it's the same for both. So we can't test moderation. Matter of fact, if we find moderation with an indistinguishable dyad, they become distinguishable. And if you have like same-sex twins, you need to figure out why you have moderation, because you're assuming that you don't, but you do. Right? So here's some questions that you can generally test within dyad moderation. You could say, do characteristics of the relationship impact how individuals influence their own and their partners' outcomes? So again, that's going to be gender in heterosexual couples. Do the roles that each person plays, like caregiver and patient, mother and child, things like that, does that influence the extent to which people, influence one another? Or are there synergistic or buffering effects within dyad members, right? And so within dyad moderation, we're going to talk about it in a dichotomous sense and also in a continuous sense, right? So in the dichotomous sense that within person moderation is that's where we're going to constrain those actor effects to be equal across partners. That's binary variable that we use to distinguish the partners. And so by constraining those to be equal, that's within dyad moderation. Same thing with partner effects. You constrain those partner effects to be equal. That's within dyad moderation. All right. You can also do this trichotomously, like I'm not sure if I have it in here or not. Oh, I do. You can have studies like this where you have triadic APIM, and you have mother, father, and child, and they all predict their own and each other's outcomes. So you can extrain it to like a trichotomous moderator, but for the most part, we're going to stay within that dichotomous moderator for at least right now. So within MLM, this is a interaction term that's created. So again, that multiplicative term. But in SEM, we can constrain the paths to be equal. And that is the best way. I think that's the most easiest and most straightforward way to test moderation. You can also create an interaction term. I just don't recommend it. It doesn't make much sense. It's way extra work, and you're just opening yourself up to other possible problems. All right. Essentially, within dyad moderation is just constraining these to be equal and constraining these to be equal. I do this in 2 separate steps. So I constrain the actors first and then the partners, or partners and the actors. Okay. So rather than running through an example, let's just go back into M+. So, all right, I should be sharing my screen. So online folks, do you see the PowerPoint still, or do you see my whole desktop?
Full desktop.
Perfect, thank you. All right, so we want APIM within dyad moderation. Again, this is going to be a quick one because it's something we've already done, right? But I want to get you all used to it. So this is where you will want to code it the long way. So again, we're using the couples.dat again, and we're going to test gender differences on relationship mindfulness in the prediction of relationship quality among heterosexual couples. All right. So we'll have our traditional on statements here, and then this will be this is our actor effect. Here's our partner. Here's our partner. And here's our actor. All right, how would I do this? What do I do to test within dyad moderation? What's my next step? Anyone know? This is where I throw on the equality constraints, the labels, right? So this is where I'll do A1 for actor 1. And M+ is not case sensitive like Lavon is. So if you do this, doesn't matter. Lavon will yell at you. All right, so you just have your on statements. And again, this is where you have to create a separate line for each one. I think technically you could probably do it all in the one line, but it gets really confusing. So I would strongly encourage you to do this, to do it this way. So I think M+ would probably run if you did this, but to me, I want all my value labels to line up vertically because it just makes it easier for me to understand. So, but if you'd rather see your whole model on one screen, that's more than fine. And so we can go ahead and run this. We can scroll down. And again, we're looking at our model data fit, that chi-square test. And what it's telling us is that by constraining those paths to be equal, those actor effects, there is significant harm done to the model. That chi-square is significant, which means that gender moderates the relationship between relationship mindfulness and relationship quality. All right. And this is where we would, we could either create an interaction plot by going back and pulling out the intercepts and the means and centering variables and things like that. This is where you can just go back and look at the parameter estimates, or you can run perhaps even a multiple group model to get those individual parameter estimates and your simple slopes. All right. But essentially this tells us that there is moderation. And so that's really, when I'm looking at it this way, that's all I'm running. That's as simple as it can be. Now we can go in and test whether or not the partner effects are different. We'll just do P1. And the one prop I will give Levon is that in M+, you have to save these as different data files if you want to go in the results. In Levon, you can create one big line of code and you can get all your results without having to change anything. So I will give Levon props there. But other than that, drives me mad. And I'm an M+ guy for life. So we can run that. We scroll down, look at the chi-square, not significant. So that means gender does not moderate the partner effects in this model, right? So there are no gender differences in the extent to which my relationship mindfulness influences my partner's relationship quality compared to my partner's reports of relationship mindfulness influencing my levels of relationship quality, right? So we do have moderation in the actor effects, but not in the partner effects. All right. Any questions about the M+ model with these? Okay. All right, moving back into the PowerPoint. And I'll tell you right now, the next model we are going to look at, that's one of the ones I said this morning isn't going to work. It's going to be that one. So just as a forewarning. All right. So now we're going to move into between dyad. Actually, before we move on, any questions about within dyad moderation? So I showed you how to do it, and I told you next steps, plot simple slopes, things like that, which you should always do. And if you're testing moderation, please provide a graph. Please provide a graph. Because you can actually misinterpret moderation. You think your effects are doing one thing and they can actually be the exact opposite, right? And that actually happened with a paper I just ran an analysis on. I had this moderated mediation, and I just looked at the moderating effect, looked at the sign, and tried to get it straight in my head and said, oh, when depression's high on the males and it's high on the females, relationship quality goes right out the window, it goes way down. Turns out it was the exact opposite. It's that the differences were only evident when there was low depression within the relationship. So you can actually interpret your results incorrectly despite having a significant effect. So just please plot. Okay, between dyad moderation. So remember, a between dyad variable has the same value for both dyad members, but varies across all of the dyads, right? And so again, this goes back to like relationship length is a between dyad variable. Number of children can be a between dyad variable, something that again is shared by both people, right? Here, we absolutely can test moderation with indistinguishable dyads, right? So with between dyad moderation, we can absolutely test differences. So this is an example of where gender, we just tested it as a within dyad moderator. Here, it can be a between dyad moderator. You have lesbian couples with 2 women, you have gay couples with 2 men in your sample. That's a between dyad variable there, because gender doesn't vary within dyad, it varies across dyads, right? So again, just be really, really careful. So essentially, the in between dyad variables, the extent to which actor effects and partner effects depend on the level of the between dyad variable. Okay, so that means our actor and our partner effects are going to vary as a function of that between dyad moderator. And with indistinguishable dyads, this is where, again, there's a little bit of trickiness involved. is when you have these interactions and between dyad interactions, you have to bring in a third variable or a moderating variable. So right here, x2m and x1m, all right? You have to bring it in to the model and test it in the normative way you would test an interaction by centering your variables and then multiplying them together. But what you do is you constrain them to be equal, all right? And so because they're indistinguishable, because they're same-sex twins, for example, you create this interaction term, all right? So these two multiplied by each other and is this one, and then this multiplied with this equals this. You constrain these to be equal, right? And then you're also going to do the exact same thing with the other interaction term, because again, they're indistinguishable dyads. Those parameter estimates should be identical, right? And so I personally have never run one of these. So I haven't written up code for this before. So that's, and we're not going to run it here because I still haven't done it yet. But I will pass along this code when I get around to it. I have a data set that you can kind of do this with. I just don't have many between dyad variables with indistinguishable dyad numbers. I have a national data set there's some same-sex twins in there, so I'm going to try to figure out something to go in there. I'll probably do like gender or something like that, and I'll pass along the code whenever you can. But that is essentially what a between dyad moderation model looks like with indistinguishable dyads. So is everyone with me in terms of the complexity of moderation, in terms of within and between dyad variables and things like that? Or are there any questions?
This might be going back a little bit. When you're doing the method of moderation, not this one, the one we just went through the example on, that doesn't give you the amount of variance accounted for by the moderation when you don't have the interaction term. Is that right?
Correct. I mean, you can test it that way. You can, if you were to calculate the typical product method, you can get that interaction term and the accounted for variance. Yep. And there's a way, if you want to do it the really long way, you can actually think back to, you can calculate your semi-partial correlations or regression coefficients, and then there's ways of doing that in M+. You calculate those, the amount of variance explained between for males and for females, and then you create a model constraint where you fix them equal to each other, and that's another way of coding it that way. It's a longhand way, but yeah. When I do these types of analyses, I generally don't report the amount of variance explained because it's almost always just exceptionally small. And I actually view it's more likely to get accepted when you don't report it, because when a reviewer two sees it only accounted for 0.5% of variance, it's gonna be like, well, that's nothing. Why are you even testing that? So it's essentially it's opening yourself up to criticism. So I don't report it unless I'm asked to, in which case I'll happily report it. Okay, so here's kind of like the sample space of between dyad moderation, and now we're going to be moving into, continuous variables. So things that vary continuously across dyads. Relationship length is that key one, and that's the one that we are actually going to be testing here in a moment. If the dyads are distinguishable, you can also test between dyad moderation with a binary variable using a multiple group analysis. So you create a multiple group analysis, and then you constrain those paths to be equal across the groups. That's another way of doing it with a binary variable for distinguishable dyads. The reason you can't do it that way for indistinguishable is then you're putting two labels on your path, and M+ is going to yell at you. Okay, so let's move into continuous between dyad moderation and M plus. This is the one that is going to yell at us. So I will make that a little bigger. So this will be right here, and then we are using a different data file. So I believe I changed the code, the data file in your files, but I just want to be sure. So let me know if that's wrong. Let's see. Actually, we're testing binary first. My apologies. We're testing binary first. I lied. All right, so we'll do that. So pull up binary first. So this is going to be a multiple group analysis. So you will have to specify the grouping variable in M plus. And so what I did is this is again heterosexual couples, same data files we've been using, but I created a older and younger partner. And so I created a variable where the female was older, and I created a variable that the male was older. Okay. And so age group, and you can name this kind of whatever you want. This doesn't have to be female older. It can be kind of fem older or M older, something like that. M plus only recognizes the first 9 or first 8 characters though. So I tend to try to keep them as succinct as I can. I'll just do M older and fem older. And so what I do first is, as you all probably know, is I'm going to run this model without any moderation in there. I just want to get a sense of the model. I want to get a sense of the parameters, make sure that that everything's working the way it should be. So I run my model. And so now the analysis is going to be slightly different. So now I increased the sample size to 200 couples, so we can have a prayer at seeing something that's actually representative of what the analysis looks like. So we have 167 dyads where the male is older and 33 dyads where the female is older. All right. So again, remember every dyad has male, female. So the older status is that between a dyad moderator. So now, again, it's the exact same thing we've done. There's no secret to this. We're going to throw in just one equality constraint now. That's all we need to do. And what this is doing in a multiple group model is I'm telling M plus constrain this pathway, this actor effect for males, to be the same in both groups. All right. And again, you can create whatever label you want here. And then you just run that. And then you scroll down, make sure everything's in order, where you have groups and your observations are in line. Scroll down. And we have 1 degree of freedom, as we should, right? 1 degree of freedom, because you're constraining that path to be the same in both groups, which frees up 1 degree of freedom. And we have significance. So we can say that that partner age moderates the relationship for men's, I don't even remember what our variables were. What are they? Dyadic coping. So the partner status, whether or not the male is older or younger, moderates the relationship between dyadic coping and relationship quality. Now tell me that's not freaking cool, right? That's freaking cool. It's really interesting. Like I saw this and I was just dinking around to get stuff together, but now I want to why is that? Because we didn't take a look at it in the previous model, but the parameter estimates are just are vastly different. Actually, I'm going to refrain myself. Normally I would just talk about it because it's more of a substantive question. But like the parameter estimates for when men are older, like it's 0.40 in terms of the effect, but when women are older, it's like 0.70. Like it's almost double in size. So age of the partner has implications for how you dyadically cope. Right? And if women are older, there might be something there to they might make more decisions. They're viewed as more mature, which they are, because I'm a perpetual 14-year-old. And so there's, I think, really important theoretical implications, and I've never seen anything like it. So when I finish my other 300 projects I have, this is the next one that I want to look at, because I think that's wildly interesting. And so what we can do now is, so now that we got this one is significant, so what I might do, since I'm not in Levon, I might say this was sig, and then I go through and I test this one, and I remove that constraint. All right, removing that constraint there, and I just make my way down the line and test all of the different parameters in this model. So again, here we have more significance, right? So whether or not the male is older has significant implications for the partner effect, or the extent to which female dyadic coping predicts male satisfaction. That relationship differs if the male is older versus the female being older. And so again, just going right down the line. So this was, and I'll constrain these to be equal. And here, not significant. So we're kind of getting there, but we're not really over the hump yet in terms of significance value. But you can see the chi-square contribution for the female being older, that's where the misfit is happening. All right, so that tells me that's the model that is more misspecified. And that leads me to maybe poke around a little bit more, but we don't have any moderation here. And then, so we say not sig.
When you're
then,
coding up like that and you're adding in, can you just remind me what that's constraining to what when you put the A1 just on one of them? Our other examples, there was like an A1 there and then an A1 on a different one.
Yep. So the A1 here, if you do that in a regular analysis, it's not going to do anything. But in a multiple group model, because we have the grouping variable,
Oh, right.
that's what this is doing. And so I could do this. A1. So I am constraining the actor paths to be equivalent to each other and equivalent across groups. All right. So we can see whether or not we should have a couple of degrees of freedom now. 3, yeah. And so now we have a non-significant chi-square test. That means I can constrain those effects to be the same across groups. Both the actor effects can be significant, or can be constrained to be equal across the groups. But again, this is where I don't like omnibus tests, is because you can have a significant chi-square hiding in there and not know it. All right. That's why I don't, when I do measurement invariance, yes, I'll test the overall omnibus test where you constrain everything, but I like to go one by one, so I know exactly where there are potential problems. Yep. So, so you all, I think I'm sensing are getting the hang of this, but are you seeing how this can bring out so much more nuance in our research than just testing a straight up APIM, right? There are a lot of different things that we can really get at that I think that people just don't. And I don't see people doing stuff like this. This is not a common practice within dyadic methods, at least in the papers I read in the family science literature. It's absolutely out there, but it's definitely something that, again, I don't see as much. All right, so we can exit out of that, and then we will go back to the PowerPoint briefly, and then we'll be jumping, I'm guessing, fairly quickly back into the between dyad for continuous. So, oh geez, I just realized we are a little bit past break. So let's take a 17-minute break and come back on the hour. So I'll give you extra 2 minutes because I lost track of time because I got too excited. And I'm going to leave the recording going because I'm going to forget to turn it back on. So. All right, so we are gonna pick back up and shift back to the PowerPoint very briefly to talk about between continuous moderator that occurs between dyads. So let me actually scroll ahead to see how much further we had to go. So we can scroll here. So here, these are just slides I'm skipping over, just outputs of what we just ran ourselves. And so we will pick up here and we will focus on continuous moderators. All right. All right, so we have I have budgeted at least an hour of teaching left. So we're going to try to get through continuous moderators, and then probably even mixed moderators, and then potentially, depending on what the group is wanting in terms of consultation or just being too exhausted to obtain new information, we can potentially go into the random intercept cross-lagged actor-partner interdependence model, or we can potentially save that for tomorrow, not knowing whether or not we're going to have time to actually get to it, because I do want to go over common fate, because that's where people tend to struggle a little bit more, is in that common fate model. So I will judge you all, or I'll judge where you all are at 4 o'clock. All right, so now we are going to look at a continuous moderator, which again is essentially kind of just a built-up version of a dichotomous moderator. The one thing I'm going to say here is, please, 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 begging you, don't make a continuous moderator a dichotomous moderator. Stop. There is no reason to do a median split or to dichotomize continuous variables. Oh my God, you're eliminating variability, you're attenuating all of your correlation coefficients, and you're not going to find something, and you're placing people into artificial groups that don't actually exist. So stop making continuous things, even if it's continuous with air quotes, into dichotomous things. Don't do it. All right. Same thing with linear transformation. Stop it. But I'm not going to go into that today. The only time I ever see it as a possibility is if you're running into model estimation issues. And I'm like, all right, I can live with it. And then you can tell me why you dichotomized. But I think there's an article by Preacher and colleagues that say there's essentially no rationale ever to do a median split or to create artificial dichotomizations, other than potential model issues. So please don't do that, because I will be reviewer too, and I will say, that is not a borderline automatic reject, but it's pretty close when you're eliminating variability. Variance is good, people. We want it. That's what we're trying to model. So keep it. So with a continuous variable, obviously we can do a multiple group model, but that becomes wildly unwieldy if we have a range on the continuous variable from 0 to 50. I mean, we have as many as 50 groups, 50 multiple group models, and your sample size in each group is essentially 1, 2, 3. It's tiny. It's irrelevant. So we need a different type of way to model between dyad moderation, and this is where that interaction term is going to come in. You can do it with a dichotomous variable, but I prefer the multiple group model. It's a little more seamless. But with a continuous variable, you really need to do the formal interaction. And this is essentially what it looks like. Is you have your continuous between dyad moderator. Notice there's the moderators only in there once, because remember, it's the same value for both partners. So if you throw a second moderator with the exact same values in, you're going to get multicollinearity. You're going to get a non-positive definite first order matrix problem. Because essentially what happens is you're collinear, which means your determinant of your matrix is 0, which means it can't be inverted, which means it's a no-go. All right. So you only need a between dyad moderator in there one time, right? And then you'll create two interaction terms. You'll have x1 times the moderator and x2 times the moderator. And then and again, this is for distinguishable dyads. And then you will have them predict each of your dependent variables. So there will be 4 total interaction effects that will be modeled. And just as in moderation with indistinguishable dyads, you can constrain them to equality and do really cool things like that. So essentially, you can have the first interaction will be the women's actor effect is moderated by relationship length. So the relationship between dyadic coping for women and dyadic coping for women will be moderated by relationship length. You can have it moderate the partner effect. So women's effective dyadic coping on male relationship quality is moderated by a relationship length, and you can have the inverse as well, the flip side of it. Where the actor and partner effects for males is moderated by that between dyad variable. And again, you can create model constraints where you set those actor effects to be equal. You can set the partner effects to be equal. You can set all 4 of them to be equal. Do whatever your heart desires in terms of constraining these effects and to provide some additional statistical evidence of your model. So essentially, the research questions that are associated with the between dyad moderation with continuous variables, are levels of spillover from conflict to parenting behavior greater among gay or lesbian couples? That's more binary. Race is more binary in relation, but marital length is going to be your continuous moderator that you can assess. So we're going to go right back into M+, and we are going to go into the between dyads moderation. All right. So we will be using couples 2.dat. And so with this strategy, we are going to be introducing a new aspect to M+ called the define command. You can bring your interaction variables into M+. You can create them in like SPSS and bring them in. I just create them in M+. So what we will be doing is we have to define our interaction terms, right? And so we are going to be testing dyadic coping and relationship quality as we have been throughout the day. And we are going to see whether or not that's going to be moderated by how long the couple has been together. So here we have our first interaction. We have dyadic coping for males, and it's going to be multiplied by length. So you use the little asterisk. And then you're going to do the exact same thing for females. Right?
Online, I'm just seeing slides right now.
Yeah.
Supposed to share my screen. I just don't know why it does that. Okay. What about now?
Got it now.
That
Good, thanks.
works.
I don't know. Something happens where I click should share my whole desktop, but it doesn't. I don't know why. But anyways, so we are going to create these two interaction terms. All right. Notice that there is no more multiple group model. All right, we don't want that here. And your analysis is still going to be the same. You can use maximum likelihood or robust maximum likelihood. My view is when you're doing interaction terms, you definitely need to use robust because even if you multiply two normal variables together, what happens? They become wildly non-normal. So you'd have to have some really odd, very skewed, very quadratic variables on the IV side multiplied together to create a normal distribution. And so, more or less, my preference is robust. So I don't really I don't ding people when they use bootstrapping or maximum likelihood, but here is probably where I would ding someone, because just the nature of the residuals and the marginal distribution even of these interaction effects is just it's chaotic, and it's ugly. Perhaps we can even once we run this, we can take a look at it. So here in your model command, it's going to be kind of the long way that we've typically seen when we want to constrain labels. And the reason I'm doing that is because if we have a significant interaction, we are going to probe that interaction using simple slopes or perhaps even Johnson-Neyman. I'm a big fan of Johnson-Neyman. I haven't quite figured out how to do it in M+ yet, but that's on my to-do list. So we'll just do simple slopes, plus and minus 1 and 2 standard deviations. And so essentially it's, you have your actor effect here, and then you have your partner effect, and then you have the main effect of your moderator, right? And you have this, the effect of the interaction, and then the exact same thing down here, right? And so remember I said we have to create some nonsense parameters in order to get this to run? Normally you would covary your interaction term with your IVs or in your moderators, right? But here we're just going to turn it into a regression. So this would normally be a with statement, but to get it to run in the M+ demo version, we're going to throw an on statement in there. All right. It shouldn't mess with the model too much. I shouldn't mention, actually, it shouldn't mess with it at all. But again, it doesn't really make much interpretive sense. We're not going to be able to interpret, dyadic coping predicting the interaction of dyadic coping and relational length. Makes no sense whatsoever. But it should be able to help us at least estimate it. And then we don't have any, I'm telling you right now, we were not going to have any significant interactions. We're going to run into problems, and I'll show you what that looks like. And then down here is if we had some interactions, this is some of the syntax that we would use to calculate the simple slopes and to create our loop plots. And so we will definitely go over this tomorrow with probing these interactions within the common fate. All right. And then M+ will do this automatically, but I don't like resorting to defaults. And I want to hard code everything in there. So I am covariating everything together. All right. So you have your on statement here. This is the nonsense parameter. You have your covariation between your dependent variables, and you have your covariation with your IVs, and these are covariation among the nonsense parameters. All right. So if you type in like with length here, if you add length here, you're going to get an error message. All right, because you are now correlating. There's a covariance and a regression coefficient going from one variable to the other. So there's two paths going from your IV to your DV, and that's going to give you all sorts of problems. So be sure that these are separate just in this case. Normally, you would not even have to specify this. So we can go ahead and run it. Go scroll down. So again, this data set has 200. So we have five independent variable, 5 dependent, 2 independent. So we're good to go. We'll scroll down. Just looking at your intercepts or your interactions, sorry. Your means and your variances are just going to be astronomical, right? Especially when your moderator, like relationship length, can actually be fairly wide. And so this is where you may actually want to rescale your moderator if you're getting issues, because M+ actually can only handle variances up to, I think it's 100,000. So like income, for example, you have to rescale it and divide by 1,000 in order for M+ to actually run. All right, so here is a 95% of the time, this is a death message in your model. All right. This is a message that is a no-go. So if you get a non-positive definite matrix, that means there's serious problems in your model. One of the times that you can ignore it is when you have a dichotomous variable, dichotomous predictor that can cause NPD matrices. And that's one of the only times why I will go ahead and ignore it. There's a couple of other circumstances where you can largely ignore them, but on average, you cannot. It means it means everything's wrong, essentially. And then you need to respecify your model. So we have perfect model fit since this is a saturated model. And we can scroll down to, we'll scroll down to standardized, okay? Because this is where I'll be able to show you where we are running into problems. So we have a significant interaction here, right? So 0.569, and it's significant at 0.003. I don't ever try to interpret interaction terms just based on this because it can get really, really funky in your head trying to figure out what's going where. So this is where you would always plot them to be sure that you're interpreting your moderation correctly. But since this is an inadmissible solution, we're not going to probe the interactions, and I'm going to save that for tomorrow when we do LMS interaction with latent variables. So pretending that we didn't get that error message, we would absolutely probe this interaction, all right? And most likely it would come out as, what are the effects? For couples who have been in relationships longer, the effect of dyadic coping on relationship quality for males, I believe that's the outcome variable, and males is the interaction one. The relationship between dyadic coping and relationship quality for males is dependent on the length of the relationship, and the longer the relationship, the stronger, the more dyadic coping influences how satisfied they are. That would be the interpretation if this were an admissible solution. So here's kind of how I know it's an inadmissible solution, and it's these guys right here. So these are our covariances between our interaction terms and our moderator. And as you can see, the covariance is 0.96. Way too high, way too high. And it's not that we have one of them at 0.96, it's that we have another one at 0.96 and yet another one at 0.96. So essentially, we do not have, like if you're in matrix speak, your variables are no longer contributing unique information. They're contributing 0 new information, which again means your matrices can't be inverted, which is how you estimate parameters and standard errors within structural equation modeling. So again, this is an absolute no-go in terms of model data fit. But again, this exercise is more about programming between dyad moderation. All right. So any questions about any of this? And no matter what I did, I couldn't get this to work. I tried centering, I tried cutting variances. It's not going to work. I think it's just one of those things where it's not a testable hypothesis. And this is where I would actually dichotomize relationship length, but I would do it I would create several different dichotomous variables as sensitivity analysis. So I do kind of less than a year, 1 to 2 years, and then I would create these different arbitrary cutoffs to see at what point in relationship length are the differences kind of coming apart. So that's how I would approach this if I didn't want to kind of give up on this type of analysis. But it's problematic. Any questions about between dyad moderation? And with indistinguishable dyads, you just add in your constraints and you're good to go. Right? That's the only difference. Add in your ISAT model constraints, and you have your syntax. All right, so moving over back into the PowerPoint. So what? I'm not sure how that happened. All right. The final type of variable that we are going to go through is the ones we see the most often, and that's going to be mixed variables. So in family science, in public health, in psychology, and even in, I would say, medicine, these are the moderators that a lot of times we are probing. Less so when you're using like an ANOVA framework, because oftentimes there's you're going to have categorical moderators, but generally, if you're within like a linear regression framework, you're going to see mixed moderators a whole lot more. And to refresh your memory, a mixed variable is one that varies within and between dyads. So depression levels varies within dyads, both partners have different scores, and between dyads, all males have different scores on depression. All right. And so this is going to increase the complexity substantially. All right. And my recommendation is you don't test any more than one continuous moderator, mixed moderator at a time. All right. Because we're going to see that you're just adding in tons of interaction terms. This is where it can kind of get a little bit tricky. You have what's called an actor moderator. And this is when an individual's own scores are on the moderating variable. You can have a partner moderator, where it's the partner scores in the interaction term that are influencing your outcome. And you're going to have multiple of these within the same model. Right? So this is where, again, it can get a little confusing. So this is a pictorial representation of a mixed moderator. And so you'll notice because the variables vary between dyad members, you need to have them in there twice. You need, let's say depression is our moderator. You need to have depression in there for males and depression in there for females. All right. And so you're going to have your independent variable for X1 and X2. And then you're going to have your moderator for 1 and 2, for partner 1 and 2. And then you're going to have the interaction terms. Right. And so that creates 4 different interaction terms, which is already a lot. And double it because you're predicting your outcome and your partner's outcome. So there are 8 pathways in this model that are where there is moderation being estimated. And so think about if you were to add a second moderating variable in here. Want to do like a 3-way interaction. That gives me like angina, like I can feel like my chest kind of like trying to break or something like that, right? Because I don't even know how to interpret that. Like there's going to be multicollinearity out the wazoo. This is one of the times where I'll actually say multicollinearity is maybe actually a problem, is when you have all these interaction terms. So again, I recommend only testing one of these at a time. Another way you can test a mixed variable, that's one way, is you can do an actor by partner effect. Right? So this is a much simpler way, and you only need to include one interaction term. You multiply the IV of partner 1 times the IV of partner 2. All right. So if dyadic coping was my predictor of relationship quality, then I multiply my levels of dyadic coping times my partner's level, and I have that predict both of our outcomes, both of our relationship quality outcomes. That's another way to test a mixed variable interaction. It fundamentally assesses a different question, but it's another way to test mixed variable interaction, right? And so I think the actor by partner effects are unbelievably cool, and they're actually really quite simple to estimate. And so when I was actually preparing this, I was kind of fiddling around with stuff, and I was doing some things using variables that I have a lot of familiarity with. And I actually found an actor by partner interaction, and I'm going to write that into a paper now. And we'll go over that example here actually in a few minutes. And so this is an actor by partner interaction. This is the simpler one, so this is why we're going to start here. All right. And so as I kind of already briefly talked about is you just multiply the IV times for each partner and you create an interaction term that way. And you just have that predict both people's outcomes, right? And so to me, this model is just kind of confusing. It doesn't make a whole lot of sense to me, like just visually looking at it. Like I kind of get it, but I kind of don't get it. So this is, I think, to me, a much clearer diagram. And what this says is the path from X1 to Y1, so the A1 path, is moderated or is dependent on my partner's level of X2, right? So if, let's say, again, depression, predicting relationship quality, if I have high levels of depression, the higher levels of my depression get, the lower and lower and lower the quality of my relationship gets. Makes sense. But when my partner is also depressed, that slope gets even steeper. All right. When we're both depressed, that slope becomes, let's say before is 0.30, negative 0.30. Now it becomes negative 0.50. When we're both exceptionally depressed, of course, neither one of us is happy in that relationship. So that's what an actor by partner interaction looks like. All right. So here's a study that I frequently cite that I think is actually really cool. And you can find some really kind of counterintuitive findings. I'm not going to go over it, but essentially the idea is when there's dual trauma couples, they actually have higher levels of relationship quality when they're both traumatized. It's because there's shared resonance. It's when one person is traumatized and the other isn't, that's when there's a lot of problems. And so you can get kind of these, yeah, I get it as I think about it retrospectively now, but you might not think about that at the outset. And I think that's, again, why I'm a big proponent of moderation. So what we're going to do is we're going back into M+ and we're going to estimate the actor by partner interaction. All right, so let's see, is it? Yeah, so it's going to be actor by partner mixed. It's going to be the input file. I need to make this bigger, so I need to find my file. So where's my input file? I think this should be it. Nope, I think that might be the wrong one. Let's see, there we go. There we go. This should be it. All right, so we are going to have depressive symptoms serve as the independent variable, and we are going to have relationship quality serve as the dependent variable. All right. And so first, we're going to enter that into the use vars command. And then we're also, I probably failed to mention this earlier, is we want to add in our interaction term. And you have to add it in at the end. So if I put interaction term right here, M+ is going to yell at me. Because every variable that you create in your define command has to go at the end. Again, one of the idiosyncrasies of M+ that I just don't understand, but it's just one I've learned to live with. So your interaction term has to go at the end. And this is a personal preference. I'm not a huge person in terms of standardizing your variables before interactions, but within M+, I found it to be a little bit easier. And the reason I don't standardize them a whole lot is because I don't know what an interaction term is in terms of standard deviation units. Like it doesn't make sense to me. I can get it at the when when I'm high on like like on a continuous scale of depression, that makes a little bit of sense to me. But like when that's in standard deviation units, I don't, it just doesn't compute with me. But again, that might be my own idiosyncrasy. But in this example, I am gonna standardize just to show you that you can how to standardize variables within M+. And if you do that, only focus on your model, on your unstandardized model results. Don't focus on your standardized ones. So we'll create our interaction term. So you just, again, simply multiply the IVs of both partners together. And then make sure you put your int up there. Again, use MLR here, especially since we are doing interactions. And actually remind me, we can look at the residuals and the marginal distributions of the interaction term. So with these, now I'm gonna, let's see, do I want to do it today? Actually, let's do it. We'll dive into the plot command today. Why not? So what we're gonna do here is in the model, we're gonna specify all of our actor and partner effects, just as we normally would. So specify those 4 effects, then add in your 2 interactions. So the interaction predicting both people's outcomes, right? And then what I want you to do is after the male, I want you to throw in any label. I would throw in A1 just because it'll be easier for you to follow here. And this is not, I mean, it is I'm just labeling the parameter. I'm actually not constraining it here. So if I don't have another variable in my model that has A1, it means I'm just telling M+ this parameter right here is called A1, and I'm not constraining it to be anything, right? So I'm doing the same thing with A2. And actually, that's on the wrong pathway. My apologies. We don't need it. It should be over here. Actually, hold on. Let's see. It's actually right here. There it is. Because it's a partner effect. So put A2 next to the partner effect on male, from female to male, and then the interaction term, put that as A3, right? So we're just telling M+, these are the parameters, and this is what they're called. And then what we're gonna do here is just your covariances, like you normally would in APIM. And then we have to include that pesky nonsense parameter, all right, just to estimate the model, all right? So in your model, it's going to be an on statement. Typically, again, this would be a with statement if you have the full version of M+. All right, so now's where it's going to get a little bit tricky. So I'm going to introduce a new portion of M+ called the model constraint portion. All right, so the model constraint portion of M+ is where we can impose model constraints and we can create new parameters. In fact, that's a lot of what we're going to be doing tomorrow, is we're going to be creating new parameters in some way, shape, and form. I mentioned those really odd little phantom variables. We're going to be creating them and constraining them to equality, and a lot of the times we're going to be using that model constraint command. So what we want to do is we want to create new, type in new, and we're going to create 10 new parameters, all right? So you can name these whatever you want, but essentially what I'm doing is I'm testing simple slopes at -2 standard deviations, -1 standard deviation, 0, 1, and 2. All right. And actually what I'm going to do is, I'm going to go over this again tomorrow, but this actually needs to be -1.5, simply because 2 standard deviations below the mean is a negative value on depression. Can't have it, right? It's a nonsense parameter. So if I have 1.5 standard deviation units, that's around 0, all right? So that's when couples would have no depression. But you can have -2 today. It's fine. It won't affect the estimation or anything like that. But in moderation, a lot of the times people say there's an interaction. but it's way outside the range of the sample. And so to me, I'm like, what does that actually matter if no one in your sample is within the region of significance and moderation? And so here, we have our first 5 parameters. So you'll see very high mod is here, and it goes down here. High mod is here, med mod, low mod, and V low mod. All right. And so what these values are, is these are either going to be your mean and your standard deviation. But since I standardize my variables, these just reflect standard deviation units. So if you didn't standardize them, you would have to type in the mean is 4.4556. You have to go through your descriptives and do all of the actual hand calculations. All right. So that's another benefit to standardizing your variables before you're running an interaction. All right. And then you'll create your second set of new parameters. And this is going to be your simple slopes test. All right. And so this is a very standard equation for calculating simple slopes. So you're going to have very high, which is A1, which is, I'm going to scroll up real quick. That's your main effect right here. Right. And then you are going to have your A3, which is your interaction effect. Right. So scroll up right here. And then we're going to multiply it by the level of the moderator. Right, all of these. So if you have 5 variables up here, you should have 5 new parameters up here. You should have 5 new parameters down here. All right. So we're multiplying the slope of the interaction by the value. So by 2, by 1, by 0, by -1, by -1.5. All right. I'll give you just a minute to catch up for those of you who are plugging along. All right, then next, we are going to move down to the plot command. And so this is the interactions that you are going to graph, and so you can visually represent them, so you can visually see them. All right. And actually, I need to change these since these were from an old analysis. All right. So we're going to plot very low moderation, med mod, high mod, and very high mod. All right. And then in the loop command, we're going to name our variable, which is CESD women. That's going to be our moderator, right? And then this first number and the second number is the empirical range that we want on our plot. So we need to specify in M plus how big we want the plot to be, from what values to what values. And so -3 represents -3 standard deviations, and 3 represents 3 standard deviations. Right? And this last number right here represents the what do you call it? So it's going to be 0.5, 1, 1.5, the space between the major units on your graph, right? And then you are going to you can pretty much copy and paste. You can copy and paste part of it and bring down your very high mod from up here. You can either hard code in 2, or you can use your value, or you can use your variable name or your label. It doesn't really matter. And then you do that for each one. All right. So you have the interaction equation, then you're multiplying it by that moderating variable to obtain those plot estimates. Actually, I'm going to remove this because that's going to make things run a little longer. So I would, if this is in your output, I would comment it out because that will make it'll take longer for your model to estimate. So we're going to give this a whirl. Okay, so it ran, and so I will, again, I'm going to just, I know some people might not be done, so I'll just pull the syntax up right there in case people are still coding, all right? Anyone have any questions on the syntax thus far? I know it's kind of a big jump from a few parameters to now you're plotting a whole bunch of stuff. So now we can scroll down. Everything looks in order. We have a saturated model. Excuse me. And here is our male outcomes, 0.035. So we do have a significant interaction, which means the relationship between male depression and male relationship quality is dependent on the level of female depression. All right. And we have a marginally significant interaction here. I'm a big fan of, I'll probe interactions if they're less than 0.10, because sometimes you can have those simple slopes be significant. It's not accounting for a whole lot of variance, but it's nice just to report because that might be again, something for future research. But since we do have a significant interaction, we are actually going to go ahead and plot it. So I tried everything else in the M+ demo version except this. You should have access to the loop plots. Let me know if you don't, and you can just follow along with me here. So the loop plots are going to show us the slope of our regression line at that value of the moderator at the very low mod. So that's at -2 standard or -1.5 standard deviations. And then we'll be able to go through and see the relationship at each value of our moderator. All right. So again, you go up to these little the view plots option, and then you go to loop plots. And we'll start at the very low moderation. And so this is our interaction term when female depression is very low. All right. And the red line is your parameter estimate, your slope. And your blue line is your confidence interval, your 95% confidence intervals. All right. And so if your confidence intervals cross 0, then you know it's not significant. All right. So here the slope is actually, it's going to be relatively flat. Not a whole lot kind of going on there. All right. And so we can just scroll to the next one, hit the next variable. Oh, it's turning negative. So that's part of what moderation gives you. We have a small positive slope here, but it can actually go down. All right, so now our slope has changed directions. All right, so we're going to keep going. Our confidence interval is getting tighter and tighter and tighter and tighter, which means our estimates are more and more precise. And this is at med mod. So this is at the mean level when there's technically 0. And then we can scroll down here and it's getting more and more and more tighter and tighter and tighter. And we can scroll down even more and we can get estimates of our slope at when the moderator is very, very high. So all of this is great, but we're kind of eyeballing it, right? So we're getting a sense of our data. and seeing kind of what the interactions look like. But let's actually go into the data. And this is where we go to unstandardized output. So we'll scroll down, model results. Here, you'll see these this new and additional parameters section. And so we have significance at medmod we're at the mean of the group mean, and we have significance when we're 1 standard deviation below, and when we're 1.5 standard deviations below the mean. That's when the interaction term kind of comes online, so to speak, becomes significant. But when we have it at very high mod and very high mod, it's not significant. So that means when women are really high on depression, the slope is non-significant in predicting male depression. So it's when women are at the mean level of the group or they are lower on depression. That's where there are significant differences. So I would have originally hypothesized the exact opposite. I would have guessed that when the female is really, really depressed and the male is really, really depressed, that's when, the relationship quality goes sharply down. This is saying the exact opposite, right? Let's see, do I plot the other interaction? Let's see. Oh, I didn't, did I? Hold on, let me see if I can find something real quick. I actually plotted the actual interaction. So if I can't find it within about 30 seconds, we'll move on. And I will try to plot it out, find it real quick. Let's see, I think it's somewhere in here. The zoom bar is going to be the death of me. Nope. Let's see if this is it or not. No, that's not it. And we'll see if I put it in the document. I'll try this one other place, and if not, I'll bring it in tomorrow and I can show you all. I'll actually open up the Word document because I may have put it in the actual. Nope, I did. Okay. Well, I will bring it in tomorrow because I did have this. I did have it plotted out. I will actually try. I don't think this is it, but it's not. Anyways, I will bring it in tomorrow. But essentially, what we see is that there are significant differences when male depression is low. The impact of female depression on a relationship quality is actually quite strong when females are high and medium on depression. All right. So it's when the male is not depressed and the female is depressed that relationship quality really suffers. But as they're more depressed together, the relationship quality still goes down, but the impact of female depression no longer exists. Right? So to me, that's a phenomenally nuanced perspective on depression and on relationships and the impact that partners can have on one another. All right. So that is the actor by partner interdependence moderation model. Any questions about that? Is it making sense? And that's why you plot, because I would have guessed the exact opposite. If I didn't look at the plot, I would have just assumed I was right. And guess what? I was wrong. Right? So always plot your stuff in moderation. Okay, so we're not going to get to the within the random intercept cross-lagged actor partner interdependent model today. So we will either start with it tomorrow or we might get back to it at the end of the day tomorrow. That's more supplementary and superfluous, and you'll have to take my class in the fall if you want to learn about it. So I'm holding it hostage, I guess. Okay, so now we will go into a study that I've been promising to get done for like 3 months now, and I still haven't done it. We're looking at sibling perpetrated abuse, family strain, and negative affect among dizygotic twins, so male-female twin partners. And so our research question is, are opposite sex twins, is victimization perpetrated by their sibling, by each other, is that related to negative affect over time? And is that relationship moderated by current levels of family strain in adulthood? So sibling abuse in childhood, family strain when you're 45 or 50, and how is that predicting negative affect when you're 55 or 60? All right, that's essentially the idea of this model. And so as you can see, all of these variables are mixed. Sibling abuse can vary between siblings and between between dyads. Same thing with family strain, same thing with negative affect. All right. And so this is our model. So you can, of course, it can't go anywhere. So we have the 4 interaction terms with 8 interaction pathways, and then we have our main effects of families of sibling abuse and family strain. Okay. We also have some covariates in there, but that's not pictured just because it's going to be way, way, way too much. All right. So that's our conceptual model. And so this can get this. I've even confused myself and creating these interaction terms was actually a freaking nightmare because I couldn't remember how I coded them. And it's the female twins reports will be how much their brother, the male twin, abused them. So it's female reports of male abuse. So I'm calling it female victimization. That's how I'm going to remember it. And we have the same thing for males. So male victimization by the sister, perpetrated by the sister. So male victimization, all right? And then we have current family strain and negative affect. And so we have one interaction that's actor for female, and that's where she reports on how much she was abused by her brother and her current level of family strain. And then we have an actor partner, which is where the male twin reports their victimization by their sister, and the male twin strain predicting. I think that might actually be wrong. Actor partner for male. So male twin abuse, that should be female twin strain. I'm sorry about that. And then male negative affect. All right. So actor partner by male. And so that's these effects here. Right. These interactions. And then our interaction 3 is, excuse me, female twin reporting how much they were abused. The male twins reported strain, right? And the female twins reported negative affect. All right. Then the 4th interaction is male twin abuse, how much they were victimized, the female reports of strain, and how that impacts male negative affect. All right. It's complicated. You following me thus far? All right. So that's these interaction effects. All right. And then we have the 5th and 6th interaction, which are going to be partner. All right. So female twin victimization, female strain, predicting male negative affect. And then you flip it. All right. Male report of abuse, male victimization, male report strain, predicting female negative affect. All right. So that's these guys right here, 5 and 6. And then finally, we have, before we did actor partner, now we just do partner actor. Flip it, right? So female twin victimization, male reported family strain, predicting male negative affect, and then the inverse of that, right? So that's all of our 8 interaction terms. And so here is the M plus syntax. And so as you can see, we've already done this, but I threw some labels on our model and on our main effect, as well as the interaction effect. These description of means here with the stars, that's a FIML line. So I'm essentially tricking M plus into not listwise deleting these cases, because M plus will listwise delete your cases if they are missing on your X. So I'm tricking M plus to not delete those by giving all of my independent variables a mean and a variance. All right. So a nice little way to not lose data. We also had covariates in the model, but I constrained I think it was 2 or 3 of them to be 0. So I think education was one of them, right? Right here, we'll just go with education and income. So again, these are opposite sex twins. I have no idea how close or distant they are. I don't know if they live in the same state. I don't know if they live in the same freaking house, right? But I would not theorize that one twin's level of income or education would predict the other twins' negative affect above and beyond the other twins' previous levels of negative affect and their own educational achievement and income. To me, there's not a theoretical justification for that. I just don't think that exists. And so I constrain those paths to be 0. But we also have, in order to elucidate the effects of sibling abuse above and beyond parental abuse, I control for parental abuse, but one twin being exposed to the other twin being abused by the parent, I think that could have an impact on negative affect, right? And so I allowed these covariates to be freely estimated and to actually account for variation in negative affect, right? So that's why you see some zeros and some covariates are not constrained. All that's based on theory. And we did have a significant interaction. And this is not the interaction I expected. We got some weird stuff, and I poked and prodded the model because that's what I do. And it was fairly consistent. We tested mediation, that didn't work. And we removed some outliers, that didn't really change anything. And we removed all of the people with whose parents were dead, and that didn't change anything. So I actually have a decent amount of confidence that this is the right way, this is the right model. But what we have is actually, so we'll go into simple slopes. So again, if you're going to hard code your simple slopes, this is what it looks like. All right. So that should be no different. And here's where we found some significance. It's when family strain was 2 standard deviations above the mean is when we found that simple slope to be effective or to be significant. So this means the more males reported that their sister physically and emotionally abused them in childhood, combined with males reporting very high levels of family strain, so 2 standard deviations above the mean, so that's roughly a 3 out of 4 on a 4-point Likert scale, so roughly around a 3.2 out of 4, increased the women's negative affect. So this was a partner-partner interaction. I never would have guessed that would have come out. Never. I would have guessed it would have been more actor-oriented. I was abused by my sister. I have high levels of strain, so I have high levels of negative affect. That's not what we found. We found is that the more I was abused as the male twin, when I have really high strain, that's when my sister has exceptionally high levels of negative affect. Super weird. I mean, obviously we have theory on why, but again, not what I would have expected. And I think that's super, super cool. And here's a plot of the simple slopes, right? You can see there's a blue line right there, the blue line right there representing our confidence intervals, as well as our slope, all right? And again, since it's positive, as sister abuse goes up, and as strain goes up, so does negative affect, all right? So, there it is. This is what I was trying to show you for the other one, for the depression one. But this does just as well. This is what, if you plotted it, you plotted all three levels, +2 standard deviations, 0 and -2 standard deviations. Only this line right here is significant, but it just gives you a little bit of context rather than just seeing one line. All right. So again, super odd, but again, this is why we test moderation, because we can find things that we probably wouldn't necessarily expect. All right. And again, I've said it before, I'm going to say it again. Make sure when you are plotting simple slopes that your values are possible at +1 standard deviation and -1 standard deviation. Because you're going to have, if you have something that is highly dense at like 3 or 4, your mean is 3 or 4, and you just have a really tall skinny distribution, and you have some really you have some outliers or more observations that are really far out in the tails. -1 standard deviation might actually be a value that's negative or not possible, because those outliers, those ones that are far way out on the right, are increasing your variation, which is by definition increasing your standard deviation, right? So you might not be able to test whether or not people lower 1 standard deviation lower. It might have to be a half a standard deviation, or you can't go 2 standard deviations, or you can only go 1.5. So be mindful in moderation whether that your values can actually take on legitimate values, and it's not just a function of, oh, hey, it's really significant at a value that can't possibly be, which again, to me, what's the point of the study then, right? Oh yeah, this is the example that I think we already went through. I found a 2 standard deviations would not work, so I did -1, 1.5 standard deviations. And this is the actor by partner model. So sneak peek, I know we're a few minutes over time, but you can do this with latent variables too. And that's what we're going to go over tomorrow, not within the context of the APIM, but in the context of the common fate model. We're going to talk about latent variable interactions, because you probably will never get that in an SEM course. And to me, it's one of the coolest things in the world. And it's a way to actually measure the constructs at the level that you believe they exist and account for measurement error, and you'll get a whole lot of significance. I've only tested these probably around half a dozen latent variable interactions. I find moderation way more often now because measurement error is now attenuated. And so we'll go into that a little bit more tomorrow, but I just want to at least throw that out there, that this is a script for an actor by partner interaction within a latent variable model. All right. So this is essentially the model that I showed you about. I showed you the syntax for. All right. And again, here's an example of some influential observations and things that you want to be careful and screen for. And here's the code again. And you can also test moderated mediation within an APIM. So you can test those indirect effects like we talked about earlier this afternoon, and whether or not those indirect effects are contingent on your partner. And so I give you code for that too, because I just ran one of these and found some significance. So that is all I have planned for today. Again, I'm sticking around till 5. So if anyone wants to ask questions or clarification or demonstrations, or you all just are tired of me talking, then feel free to head out. But I'll be around for at least another 55 minutes if that would be helpful to you all. So I will see you all in the morning. For those of you who show up in person, I will have bagels and coffee here to give you energy. So I'll see you all, to those who are ready to be done, and I'll hang around for those who are ready to, if there's any other questions or anything left over. These.